Hello, calculus students and seekers of truth. Welcome to the continuing lesson on integration by parts. And in this example, I'm going to show you a scenario where you may have to do integration by parts twice. Okay? And just as a reminder, this is the formula here for integration by part. It is nothing more than a rearrangement of the product rule. And in every integration by part problem, what we have to decide first is what's going to be f and what's going to be g. Now, if you notice here that x squared here, if I continue to take the derivative, if I continue to use to figure out f prime, this expression here is going to get simpler and simpler. So that's usually a good choice for f. And then e to the kx here, that's going to be my choice for g prime. And I like to just write out what f prime is going to be, just so that I don't get myself all confused. So f prime is going to be 2x, and g, I'm going to take the antiderivative of e to the kx. So that's going to be 1 over k e to the kx. All right. So just having that there helps me to avoid some minor errors, and then I can apply the formula. Well, the integral that I have then is equal to f times g. So f is x squared times g, which is 1 over k. So I'll just put that over k e to the kx minus the indefinite integral of f prime, which in this case is 2x, and then times g again. 1 over k e to the kx dx. All right. Now, in most of the simpler cases, I can figure out what this antiderivative is going to be. But if you notice here, I end up with kind of the same issue again. The antiderivative of x e to the kx, that's still complicated. So we're going to have to do integration by parts on this integral. So I'm going to do a couple of things here. Let's just rewrite this expression and just clean up the work a little bit. This k is a constant, so I can just pull that out to the front. And then what I'm dealing with here in the big brackets is the antiderivative of 2x e to the kx dx. Okay. And I'm going to repeat this process. I'm still going to use 2x here as f, because when I take the derivative of 2x, the expression is going to get simpler, and e to the kx is going to be my g prime. And same as before, I like to write f prime and g prime, or f prime and g separately. So f prime is simple enough. It's just going to be 2. And then g, which is the antiderivative of this expression, is same as it was in the previous step. It's going to be 1 over k e to the kx. And then I'm going to work out this detail here. So this antiderivative right here is equal to f times g. So f is 2x. G is 1 over k e to the kx minus the definite integral of f prime, which is 2, times g. 1 over k e to the kx dx. And don't forget that all of this is wrapped in that square bracket. It's part of a greater answer right here, the entire problem. Okay, so now it's a little bit messy, but actually most of the work that I need to get done is done. So I'm going to work on this part right here, the antiderivative. So this is just 2, there's a constant, right? But the antiderivative of e to the kx is just 1 over k e to the kx. plus a constant. There's a subtraction sign here. And then the rest of this, I'm just going to copy down. It's all the same. 2 over x, or 2x over k e to the kx. All of this wrapped in the square brackets. Okay. All right. And then let's see what we can do here. We can distribute and maybe clean all of this up a little bit better. So I get x squared over k e to the kx. We can distribute this 1 over k, so minus 2x e to the k, oh, there should be an x here, to the kx. All of this over k squared. Remember to write neatly, make a clear distinction between your k's and your x's. Distribute through here, you get positive 2e to the kx over k cubed. Okay. All of this times negative 1 over k plus a constant, but as we've learned from before in working with differential equations, that's just going to be another constant. Some other ways that you might see this written, because you might take a standardized test, you will see people factor out. Notice that we have 1 over k e to the kx in everything. Okay, so this piece here, 1 over k e to the kx, you could factor that out. So e to the kx over k, and what you have left is x squared minus 2x over k plus 2 over k squared plus a constant, of course. Okay. So you may see some different versions of this. The point is, the big picture here is that when you're solving these problems with integration by parts, you may have to repeat the process. Most of the time, this integral right here is enough for you to evaluate. Sometimes, like in this case, it's a little bit more complicated and you have to keep going. As always, keep working hard. Ask for questions when you need help. Thank you for watching and have a wonderful day.